less than almost 50 always join all the time, and I have records. So please encourage them to join, because I would have to submit attendance as well and use it as part of your score. So kindly encourage them to join as well. I don't know why we're supposed to have over 80 students, but then almost all the time you have less than 50. Kindly encourage them to join. Do we have anything to address before we start the class? Is there any concern that you would want to share with me before we start the class, please? If there is none, we have one?
Doc, I have a problem with the
Please, who
S.
is speaking?
This is Frank.
Okay, all right.
The SC2 treatment, where the soil has to be collected from where it is contaminated to be treated and then brought back. My question was, we know that these chemicals they sink deeper into the soil, and if they are going to collect sample or maybe collect, I mean, is that going to be a sure way, a sure process that will get rid of the chemical? Because like they'll take it away and bring it back. If I understand that, I wish you could throw more light on that one and then address my question too. Thank you.
Okay. Yeah, even that will be answered, but then I was talking about maybe general maybe challenges that you've been facing. The email, I think some individuals reached out to me concerning the email that I provided. Frank, your question will be answered when the class begins. With regards to the academic work, but I am just taking some concern concerning the challenge of you sending your work and all that. And out of 80 something students, I have only received less than 25 of your assignment. Individuals have submitted their assignment. And please, if you haven't, by the close of the day, kindly do well and submit your assignment so that I can add up to your scores. Your assessments as far as assignment submission is concerned.
Hello, Doc.
Hello,
Doc.
hello, Doc.
Yes, please. Yes, please. Frank again, right?
Doc,
Yes, please.
Okay.
I wanted to say if the email may be giving problem, can we confirm with WhatsApp message as well?
Can you
Because
confirm with
I
what?
can with maybe WhatsApp. WhatsApp will take it through WhatsApp as well. Because that's the
I don't
challenge.
seem to. I don't seem to get you, please.
I'm talking about the submission of the assignment.
Yes, you mean you should send it through WhatsApp?
No, we've done that, but here's the case. It says it's less than 25, and so I'm myself. I'm not too sure whether mine came. So I sent it twice
Have
anyway.
you
But
received? Have you received? Have you received? A message from me. Anyone who
no,
has
please.
submitted, I have seen it and I have replied it. So if you
Hey,
haven't seen any message from me, it means you have not submitted it.
the man has not come. I sent it.
we are trying to send it to, but he said the email is not found.
Have you checked the email or have you paid attention to detail concerning typing of the email?
Yes, please. Even your
Can,
picture is there.
can we send it through the WhatsApp too?
Come again.
Can we send it through the WhatsApp too?
You sent it through WhatsApp to me.
Uh, if
Why?
if the email fails,
But there are individuals who have sent the mail with the same email address.
okay.
I'm I'm having challenges that if I
Please,
send, I just
anyone here who has submitted his or her work, let us hear from you.
Yes,
I
please, Dad, I
submitted mine,
submitted mine. I submitted
and you
mine.
acknowledge it.
And you
And
comment, yeah, you
what was the mistake? Come again.
you message back that received. Thanks.
Is it the
Yeah.
same email?
Yeah, same here too.
Yes,
Correct.
please.
Same
The
email.
same email.
So why
But
are others
Same mail.
complaining?
I said the problem is that in fact when you are sending it, initially you encounter some difficulty. You
Why?
have,
What is the challenge?
I don't know whether is the typing of the email or whether we
Yes, so you have to
wrong
pay attention to
correct.
I'm
detail.
sure, yeah, I'm sure it's the typing. Mine, I had it just once. And I just did know it went. Maybe it's the typing.
You have
mine
to
for
go
instance, doctor
and
picture is there, but if
if
you send it, you say
after
email is not
it's
found.
like after the D, eh? Then you type the is it the dot or the this thing? You have to backspace it before you
But the
uh
boy went got a gun. 5:30.
So please,
pardon.
Is there any backspace? There's
to
no
cut the
backspace.
long
So maybe
to
the
And
cut the
if
long
underscore.
story short,
you don't do it, it will not go. Between
to
the
cut the long story short, please, to cut the long story short, please pay attention to detail when you are typing the email. It's D dots bats Kobina, and the bats Kobina, in between the bats and the Kobina, there is a hyphen,
Yeah.
and then you type at stu dots ucc dots
Good.
edu dots gh. That is the email I provided for you, but some of you were just typing something different from what you see on your slides. That's why you have challenge sending the work. So attention to detail as a science teacher or as a science student is also very important. So kindly pay attention to detail when you are typing the email.
Dog, play, I
Yes, sir.
sent my yesterday, but I've not received message. You have seen it. When I type
Did
your
you
picture,
did you
and
type directly in the mail, or it was in a Word format?
it was in a word format.
Bashiru, I have replied your mail.
Ah, okay. I didn't see. That's why I've asked.
Say,
Yes, please.
say, Juliet, what about
Okay.
mine?
Have you checked your mail?
No, say, because of the lectures this morning, I haven't checked.
So if you ask what about mine, I don't understand you.
Hello, sir.
It's
Yes, sir.
because you told me to send it, but that's why I want to know whether you've received it.
Okay, kindly check. If I have messaged you back. Okay.
Hello, sir.
All right. Yes, sir.
Good afternoon.
Please, can we get few concerns and we move? Yes, sir. Please, I'm listening.
Yes, to cut a long story short, if you can type your email in the message box for everybody to get it once and for all.
I don't understand. Whilst I have it on my slides, how is
That
it
is what
different from
some are
what I'm going to
using.
type?
That is what some are using, and they are still getting it. But maybe part of the slide has been cut off. So if you can just do the Anna, just type it in the message box whilst we start with the class, so that anybody who can even go back to the messages, pick and use it. Because you remember I called and inquired about it, but then I hadn't sent mine, but I didn't check no, because I called because of the concerns that were raised on the platform. But when I sent mine, it went, I just one click, it went. So, email and people are not, they are all not
Have you
comfortable
sent
with
your
some of
own?
things. Yeah, I've received
By
my, I
yourself,
received my, I've sent it. I've sent it and you've answered it. So I'm
Okay.
okay. But what I'm saying is, if you can just type in the message box for everybody to have it, please.
All right. Can we have the can we start the class, please?
Yes,
Yes,
sir.
Doc.
Yes.
Yes, Doc.
Bring
So
the full house so we
Yes,
can
Doc.
start.
Please, you can start.
Bioremediation. I think we got to. Did we cross this side? Please, where exactly did we get to? If you can just remind me, where exactly did we get to? I think last week. Yes, Prosper. Prosper. Johannes.
Yeah, I think we ended at disadvantages of is it remediation or something like that.
Okay, so we're done with bioremediation. We started and we were almost done with phytoremediation.
Yes,
Did we
please.
start with phytoremediation?
Yeah,
Did we
yeah.
start with
If we can start
phytoremediation?
from if we can
Fight
start
to
from fight mediation.
yeah. Let's Shanti.
No, we didn't start. Oh, we got to
We
here.
didn't
Then you
start.
said that
Yeah,
when we can. Yes.
As I'm saying, we should start from here. If
yeah.
it's not
We can start from here.
Okay, all right, that's okay. That's fine. So, bioremediation, we are done with bioremediation, and in short, we're discussing how some living organisms are used to, reduce contaminant to its tolerable form in the environment. I think we are done with the discussion section. So, if you can kindly mute yourself, I'll be grateful. Kindly mute yourself if your mic is on. Okay. So we are, continuing the class and then looking at phytoremediation. So we are actually not using microbe this time. We are actually using plants. So when you
Hello. Hello. Can someone hear me?
Yeah, we can hear you.
Yes.
Yeah, we are hearing you.
Yeah. It's off.
Yes.
Okay.
hello. Please for your
Hello.
is that
Thank you.
is I should tell you- he said I should tell you that his laptop is off, so let's wait for a while. He will connect it and we get back.
Okay. All right.
Mr. Ajuman.
Yeah.
The
Thanks.
lat
Yeah.
the laptop is off, so
Now
let's
the
hold on
laptop
for a while.
on the Ojuma.
Emmanuel,
Mr. Joy.
is Prof used Thomas Musa's laptop?
Mr. Joy. Mr. Joy. Please, anybody who has his email address collected can tap it for us to pick it.
Example, the email, babe.
Is that it, Madam Anita? Madam Anita,
Yes.
were you able to submit the assignment?
Yes, so mine it was even one touch.
Okay, and send me his email now.
Okay, maybe lecture.
Okay, look as if somebody has even tapped it. Okay.
So he said he's trying to fix it. So let's wait. We are still waiting. I mean, he said sometime he's not coming back. He will get us informed. So please, let's hold on.
My end to lights out. 17% battery. Someone.
Hello.
Hello.
Please, I've posted the email address on the biology platform. Debate dot hyphen Kobina at students.ucc.edu.gh. Please kindly go there, copy it, and submit your assignment if you have not done that. It's a means of assessment, please. Don't let us have biologists and don't let us have any bad image. Let us go and submit it. And then the other one to his WhatsApp, Nana Kwafo. Let's try and do that by Wednesday that he has set the deadline. We are ending the program and anything can come. Like as they say, last days are always dangerous. So please kindly go get the email. If you have not done it, just let somebody help you fast and then submit it before the close of the day. So Sai is back. So let's welcome him.
Yeah, sorry. The machine went off again. I don't know. It's not an old machine though, but then I don't know why. Maybe overheating or something like that. Because since morning I've been using it, so that could be a challenge as well. Forgive me for such inconveniences. So let's continue.
Say.
Yes, sir.
To solve it, use air conditioning behind it. Maybe the voltage and the heat is too much. So get air conditioning in the office.
Ima,
Yes, sir.
I hope you know we are living in Ghana and then electricity tariffs.
It's true though, but you cannot live in heat like that too. So get air conditioning for the office.
Yes, sir. Yes, sir.
Thank you.
I've taken notice of that. All right, so let's continue. So phytoremediation simply has to do with the use of plants, just as the bioremediation has to do with the use of microbes and other organisms to reduce contaminant to a tolerable level in the environment. We are now using plants phytoremediation, and I'm sure it's two words combined, phyto and then remediation. I mean, bringing back the soil or the environment to its usual state, or the state to which it was contaminated before it was contaminated. So just as is mentioned, we're using plants. An individual asked a question, I think Frank, before the start of the class, that some nutrients, or better still, some contaminant seeps so down or deep into the soil such that it's quite difficult to remediate them. No matter how deep these organisms, or better still, these contaminants seep or leach into the soil, probably below the water table. That is why we use the remediation. These organisms, especially with the augmenting, okay, we use these organisms, we introduce these organisms, below the water table. So wherever the nutrient has seeped into, or the contaminant has seeped into, they could be remediated. But the disadvantage with the bioremediation has to do with the timing, and then also the conditions of these microbes to act. Frank, are you there?
Yes, Doctor.
Great. So it has to do with the timing and the conditions, that are provided for these organisms to, act. And then also, you can also talk about the quantity. I'm sure when you were reading through the slides, you came across the disadvantage of bioremediation. It has to do with the quantity. The quantity of the contaminant will also determine how fast these, contaminants are, remediated, or better so, the environment is remediated or brought to a tolerable level for use by other organisms, or which will be habitable by other organisms without causing any harm to them. So yes, they leach down but some microbes are introduced, I mean, deep down into the soil or even below the water table for them to act on these organisms. But you have to provide them with, I mean, very good conditions for them to act. So phytoremediation is the use of plant to remedy contaminated soil, sediments, and groundwater. So mechanisms employed by plant include accumulation, compensation, and then volatilization, degradation of organic and inorganic pollutants. Now, the duration depends on several factors. If it has to do with remediating with, or I mean, embarking on remediation using plants, it depends on the type and the number of plants being used. It depends also on the type and amount of harmful chemicals present, that is the pollutants which are present, and then also the size. And just as Frank, I mean, brought it up, the depth of the polluted area, the type of soil, and then also the conditions that are present for these organisms, or better so the plants, to act on these contaminants. These are factors, or I mean, very, very important conditions that when it comes to phytoremediation, you have to really consider and then take note of. So let's look at phytoremediation techniques. Just as we had for the bioremediation, we also have some techniques for phytoremediation. One is phytoextraction, two is phytostabilization, three, it goes on and on and on and on and like that. We have different, I mean, remediation techniques. But let's look at the few ones that we have. The phytoextraction. It is the uptake of contaminants from the soil by plants through translocation and accumulation, mainly in the roots and other tissues as well. It could be the stem, it could be the other organ, which is the roots. It can also be the leaves as well. It could even be in the fruits. It can be in the flowers and all that. All these organs are capable of storing some contaminants, but it depends on the plant species that you are using. So plant biomass is then harvested and subsequently incinerated. So the entire plant that you use for the remediation can be now uprooted and then tested with the presence of such contaminant. And if it is present, or if it had uptaken it, you have to just destroy it by incinerating it. Right. So the second one is phytostabilization. And this is the use of plant to reduce the mobility, that's the movement and bioavailability of pollutants, either by immobilizing or by preventing their migration. That is their movement. They can seep down, they can move from one point of pollution to, or polluted area, to another. So you have to stabilize them, and that's the technique that we use. Frank, your hand is up again.
Yes, Doc. I wanted to know that if these plants absorb those toxics, does it affect their tissues? And how long will you know that up to this time they have absorbed, or is there any sign that they show that they have absorbed, so that you can
Very good.
now and destroy them?
Very good. So you test them, you test the presence. That's why I said you test the presence and the quantity of these contaminants that has been absorbed by such plants that you are using for the remediation. Okay. So you do qualitative test.
Oh, okay.
Right. So the third one has to do with the phytostimulation, and it has to do with, Frank, I think you have to put your hand down. So phytostimulation has to do with the enhancement of microbial activity for the degradation of contaminant, typically around the plant roots. Just as some rhizobium and azotobacter and those kind of things also, I mean, fix nitrogen or nitrate into the root of plant for it to be absorbed. There are other microbes that can also, I mean, orchestrate the absorption of these pollutants by the plant root hairs, and that is the stimulation. You stimulate these microbes to act so that these plants can absorb the contaminants, and they act by breaking down these contaminants into absorbable form that could be done by the plant. So we also have the phytovolatilization, and that has to do with extraction of volatile elements such as selenium and mercury, in some cases from sludge and soil by plants, and releasing them through transpiration to the atmosphere as a detoxified vapor. So this time around, the plant is not storing it. It absorbs it and it moves away from the plant into the atmosphere in the form of vapor. That is those volatile compounds that has been mentioned. And some examples have been mentioned already. You also have the rhizofiltration, and that has to do with removal of toxic metals from groundwater or elimination of aquatic waste. And these material are done, or this material absorption are done by the plant root system. We also have the fourth one, or the sixth one, sorry, called phytodegradation or rhizodegradation. Now, anytime you hear rhizo, the reference is to roots of plants. So we have the breakdown of these pollutants occurring either through the metabolic process inside the plant tissue, and in this sense, we are referring typically to or specifically to the roots, or by the plant enzymes secreted into the soil through the root hairs. And these plant enzymes act on organic pollutants and mineralize them. Now we can talk about, since we've talking about some techniques that are involved in phytoremediation, we can go on and look at some factors affecting phytoremediation. And one, we have to look at the growth rate of the plants. We also have to look at the rates of biomass accumulation. I mean, how much it could be accumulated into the plants for it to be incinerated or destroyed, or better say, if it has to do with phytovolatilization, how much of these volatile compounds can be absorbed by the plant, and then it moves out of the plant through transpiration. If it has to do with the accumulation or the translocation, how much could it be accumulated in the plant's organs, the roots, the stem, and the leaves, or better still, maybe the flowers. We also have, yes, Frank.
Look, I'm disturbing because I want to carry out the project on this. That's why I'm disturbing. I want to understand it better.
There's no problem with that. Your understanding is key to me.
The phytovolatilization and the other ones. You see, one of them will accumulate, and this one is like it will not accumulate. So,
Yes.
do you have different plant species for that, or is just a one plant that is used? Do you how? I mean, I want to get it better because at one point in time, which plant is going to accumulate, and at another time, which one will allow it to move into the atmosphere?
Yeah, so we have different species of plant that are, going to be used for these particular purposes or tasks. Okay. Yeah, some will volatilize it. Will absorb the volatile compounds and throw it into the atmosphere. Or we have other species that also accumulate them in their, the roots. They can accumulate them in their stem. They can accumulate them in their leaves. We have different species of plant that are responsible for doing such.
Okay, thank you, Doc.
Great. So let's look at some other factors as well. So we have tolerance to the pollutants. There are some plants, when you use plant species, when you use them in this process, just as we just discussed it. The question of Frank came up and then we discussed it. We have some specific species of plants that are supposed to be used for this, purposes. So it's not all plants that are tolerable to these pollutants. Some of them will absorb and die as a result of the accumulation of these harmful substances in their tissues. Others to accumulate them will not die, but then you have to incinerate them and dispose them. safely from the environment. So tolerance level of the pollutant to the plant species is also very important. We also have the uptake of water and contaminants. I mean, I was supposed to write the rate of uptake of water contaminant. So you have to look at, I mean, how much has been, I mean, has seeped into the underground water, and then also how much is being taken up by these plants tissues that we have used them for such remediation processes. We also have to look at a certain factor called the, I mean, the rate at which this transportation of contaminants are done, the fate and the transport of these contaminants. Now, if you are disposing them, the plant you test, you run qualitative tests on these plants, and it shows that they have absorbed into their tissues, or better still, they have been volatilized into the environment, or they have been transferred into the environment. Now, what is the fate? How are you going to? It's still a contaminant. If it has been volatilized into the environment, of course, inhalation of mercury could cause serious metabolic disorder for humans and other organisms as well. So, in case of the, I mean, in case of through the process, this contaminant, that is the mercury, has been volatilized into the environment or has been transferred into the environment, what happens to it? How do you assess the quantity that has been, that has evolved from the plant into the, environment for it to be inhaled by living organisms? That is a serious consideration, or a serious factor that you have to also consider. The fate, and then the mode, those which will be incinerated. How after the incineration entirely, you still have some the compounds. So how do you get rid of this compound that has been taken up by the plant and the plant has been incinerated? How do you do that? And even through the process of incineration, some amount of vapor carrying these toxic substances could get into the atmosphere and will be inhaled, or in the environment, and it will be inhaled by living organisms. So how do you check all those kind of things? It's a factor that you have to consider. Let's look at the advantages of phytoremediation. Now, that's why we are looking at some, challenges that we have with phytoremediation, of which we are going to discuss briefly. Let's look at some, waves of goodness that has been attributed to phytoremediation. So it is relatively inexpensive as compared to our traditional way of getting rid of pollutants in our environment, such as the use of landfill sites and the rest. Of course, they help, but I think relatively the use of plants to extraction of these pollutants is expensive relatively, and it's also aesthetically pleasing. Like I mentioned, landfill sites, it's not pleasing. It doesn't give a pleasing sight. Okay, it doesn't give a very good sight when you are walking and the whole place is messed up with refuge and the rest. Other pollutant as well. So yes, you might not know even the plants that you have there is absorbing or cleansing the environment or reducing the pollutant to a tolerable level, but then it will just be there and will be working for you. So, and it still give you some aesthetic, beauty, add to aesthetic beauty in the environment. So plant vegetation, the next thing is plant vegetation on site also reduces erosion by wind and also by water. And of course, which it covers the soil directly from the exposure of the sun as well, to drain the soil water or to increase rate of evaporation. And it is to maintain, it do so by maintaining the soil water. And then also it checks erosion as well, such as serving as rain breaks and all that. Right. So we also have the point of it providing wildlife habitation to other organisms. And so organisms like birds and then other organisms will settle on it, feed on it, and aphids, birds, monkeys, and the rest, they will use those trees as habitation or habitats. And then also on-site solution. This one has nothing to do with you moving from the site of the pollution or the contamination to different sites. You plant the crop, or better still, the plant, the tree, at the site of contamination, and it does the work for you. And some valuable metals can be recycled. This with this type of, remediation, some valuable metals can be recycled and regenerated into the soil. Some compounds, after being destroyed, they move into their ions or in their ionic state, and they recombine with other useful metals or compounds that are being used or absorbed by the plants and used. So it is easy also to monitor. You can run qualitative tests on it to check the level of contamination or pollution in the soil and how far it has gone with absorption by these plants. So no maintenance once instituted. There is no maintenance. You don't need to. All what you have to do is that you just have to, after testing and knowing that these pollutants have been absorbed, you just have to, cut down the plants or the tree, and you have to incinerate it to maintain the level to which it will be tolerable to the living organisms in the soil specifically. Now, there are some disadvantages. In as much as we have some advantages, we have some disadvantages as well. This obviously takes a long time for it to occur. Now, it only also works with low contaminant concentration. If the concentration of the contaminants are very, it's low, you'll be sure that you have all of them, cleansed, or better still, remediated. But if you have it more, it will be difficult for, depending on the population of the species of plant that you have on that particular site, it could work for you. If it is more, you have more of the trees or the plants on site to cater for such contamination. But if you have few, then it should be also sure that there will be some remains of the contamination or the contaminant. So it only works with shallow contaminations. You know that even, the deepest part of the plant into the soil, it has to do with the taproot, and the taproot cannot get, below, even it cannot even get to the water table. So you'll be sure that those which deep down into the soil will not be absorbed or will not be catered for when it comes to the contamination. And then also volatilization of compounds can transform a groundwater pollution problem to air pollution problem. Just as I mentioned, the fate, we consider the factors, one of the factors as the fate and the transport of these contaminants. So if it has, you have redeemed the underground water from pollution, what happens to it being, transmitted into the atmosphere or being transpired into the atmosphere? What happens to those living organisms that are respiring and taking in such polluted air? What happens to them? It's a disadvantage. So the fifth one has to do with the plants that absorb toxic material may contaminate the food chain. So like I said, it can be absorbed into the roots. These contaminants can be absorbed and be kept in the stem, and they can also be absorbed and kept in the fruits or in the leaves. Now, don't forget that we have different plant part storage, or different parts of the plant that can be used for storage, storage of excess food that has been produced by the plants. And some of them store their excess food in their roots. Example is cassava. So just in case these contaminants are absorbed into the roots of the cassava, or the cassava has been planted in a site of contamination, and then these cassava absorb it into their roots. Of course, if you go and eat such cassava, which has absorbed mercury into its roots and has not volatilized it, or better, it has not transpired it into the atmosphere and is still in there. What you have to do is that you have to, transmit it from you to successive food, those organisms in the food chain. Of course, if you have it through the, herbivores, such as the sheep, goats, and the rest, taking the cassava, you also have to go and kill these organisms and feed on them, and it continues like that. If it has to do with grasshopper, like the food chain that we all know and we have studied in SHS and the rest, grasshopper through to this, a feed to be fed by birds, and human will feed on these birds, and that kind of chain. These contaminants can be transmitted through this level of chain, and that's dangerous as well to our health. So it is also less efficient for hydrophobic contaminants, and which bind tightly to the soil. When we say hydrophobic, these contaminants do not react with water, so they will not be dissolved. Even if you have water available, they will not dissolve in the water, so they will still be tightly bind to the soil. So that should end our unit 3 for us, and then we'll go on to look at the unit 4, which has to do with some applications as well. Yes, Frank.
Oh, Doc.
Ye-
I think one of our lessons in molecular biology, we got to realize that the Galamsey site, what they are doing, those areas especially, in the next 10, 15 years, if nothing is done about the Galamseying, I will be giving birth to babies that may even have 3 heads and other stuff, some parts will be missing. And even some people were saying that it is even happening. And so, if we have this solution, why are we not employing it? Is it that the plant species are not available here, or just a mere wickedness, or is like people are not exposed to this?
Okay, so you have made a point, and your point is valid. In as much as your point is valid, we also consider disadvantages that are associated with this type of remediation. I hope you took notice of that. The disadvantages. You
Yes,
said it is
please.
very slow. Okay. Looking at the population of the country, and we now going to plant for these trees to, grow up, mature, start absorbing these harmful nutrients, and even some of them are, I mean, volatile compounds. They will be transmitted into the air. We will inhale it back, and the rest. Okay, so every remediation process or technique has its disadvantage. You can't get it 100%. And it's not that the leaders are wicked or they are not employing this technique. Okay, but just that this remediation also has its own disadvantage as well. It has its own disadvantage as well. So that is it. The introduction of these microbes to degrade the pollutants in our water bodies. Now, after they degrading the pollutants in our water bodies, what happens to those microbes that you introduce into our water bodies? Have you thought about that? Frank, have you thought about that?
There are some.
Have you
Sir,
seen it?
hello,
Yes,
sir.
sir. Yes,
A
sir.
follow-up. I wanted to ask a question, then Frank came in with his own.
Okay.
I think last month there was this news bulletin that people within Western region eating contumely
Yeah.
that is infected with cyanide and mercury.
Yeah.
And here's the thing, we're also talking about this issue. And that is
Sure.
why I think that's where Frank is also coming from. So can't we do phytoremediation to take away this kind of harmful chemicals from the contaminant that people are already consuming? Because if I eat this contumely or I eat this cassava, food chain, I'll give the hacks to my goats, which also have this kind of food chain line. So eventually, the whole population is going to be wiped off or going to be also affected by this whole thing. What can we do about it now? Just as you said, it has its pros and cons. So can't we wait and see the one that will favor the nation and employ it?
Right. Right. So we've spoken about two. we look at the traditional way of, I mean, resolving the situation, and that is what is being employed in Ghana right now. I mean, addition of chlorine, addition of alum, and addition of and those kind of things to coagulate those toxic, I mean, pollutants that are introduced into our water bodies, such as mercury, cyanide, and the rest. This cyanide and mercury that you've mentioned can also seep into the soil and are being absorbed by the plants. Now, if we can also go the biotechnology way of introducing bioremediation, phytoremediation. Now, the pros and then the cons, we have discussed that already. Now, let's look at the cons of the bioremediation. I just mentioned it. After introducing this microbes, okay, into our water bodies and our soils, how do we get the after they, I mean, doing what they're supposed to do? What happens to them? These microbes, what happens to them? How do you get rid of them? Because they also have generation time. They reproduce. So how do you get rid of them? You are looking at the cons as well, not only the advantage. Now, the next thing is that you have these food crops absorbed. Okay, these food crops absorbing these toxic substances. Now, what we have to rather educate our people is that those food crops that have absorbed these harmful and toxic substances, we should not go and be eating them. Just as it was mentioned in the phytoremediation, the process has to do with you incinerating them. You have to incinerate them, okay, in a controlled manner. How do you gather all the contomere in your village? How do you gather all the cassava that has absorbed this, I mean, harmful substance in your town? How do you gather all the cassava? How do you gather all the plantain? You see, it's difficult. On the face of it, it's easy, it's nice, it's interesting, but the application is the problem. Senior, if we can have a way of going about this, everybody will be happy. Everybody will live a happy life. But then, it's not as easy as we are discussing. It's just an idea that we are selling out as biotechnologists, and it could be carried on a large scale when there is compliance by the citizens of the country. You can't tell your old woman to stop eating contomere in a polluted area. It won't happen. They will insult you. Yes, Yusuf.
So my hand is still up. I've not finished.
Okay, all right, Ima.
So, sir,
Yes, sir.
you see, this is a very dicey situation that we find ourselves in, because either we go bioremediation, phytoremediation, or sensitization. The thing is already happening. You get it? It is happening. Yes, as you said, how can we go around the whole of Western region and then gather all the contomere? Look at the food chain that is going to be lost. All the contomere, all the cassava.
Yes.
And then we say we are going to incinerate it under control. The cost involved. So my question is, why should we wait for us to get to that point in time? This Galamsey issue, I don't want to sound political. We've been talking about it, and we have politicized it, and it is killing us. It is killing us. Just as Frank said, from the last lecture that we had last week, we made aware that, I mean, it's unbearable. Ghana company has given us assurance that in the next 5 years, we'll be importing water. The question is, how much can we import water? If others have money, me and Frank and other colleagues here, how much water can we buy in a day for us to use till God comes again? So the last time,
so your concern is valid. Ima, not to cut you. Your concern is valid. You see, that is why we have to be responsible as citizens. We need to be very responsible as citizens. In as much as we are waiting on the government in power to, I mean, curb Galamsey and other pollution problems, okay, we need to be responsible as citizens. Your car, the exhaust, the those exhausts that are, I mean, exhuming from the back of your car. Have you checked that? Have you checked the burning of stuffs in your homes, in your houses, around your places? Have you checked that? Are you only considering water pollution? You also have to consider air pollution. The land that you are polluting, have you also considered that in your own small way? You see, the small things that we do daily, also add up to the pollution of the environment that we are discussing. Okay, and they
Say,
all go a
I
long way to
understand you.
affect all of us as well. So we
Say,
have
I
to
understand
all
you
be
perfect.
responsible in our own small way to curbing this pollution problem. Other than that, it will still persist in the environment. It starts with me and then it continues. But then if you are not ready to take the starting point step, then expecting others to do it will be quite difficult.
Very
All
good.
right.
Very, very good point, Ray. Say, sorry for, me and Frank
That's
today.
no
We are
problem. Go ahead. Go ahead.
now. I remember with this other pollution that you just talked about, we are not looking, we've always neglected the backdrop that is not that harmful. I remember during President Kufuor's time, a law was passed to ban black polythene, which you all know it takes 50 to 70 years before one can decay completely. To ban it. And when they took this legislation to parliament, they refused because people have their political interest in it. And so you see, at times, some of these things it ends at the bar stop of government and it ends at the bar stop of individuals. Holistically, if Kenya, was it is it Kenya? Where is this man? Rwanda has been able to ban polythene bags, has been able to ban all this kind of thing. Why can't we do it as a country called Ghana? It is because we don't have um what you call laws and legislation that will back some of these things. So you don't have any control. We will do all the sensitization, we will do all the education, we will do everything. Somebody in my area where I live, Tema, they will ask you, is the land for you? Do you sleep there? Oh, yeah. Do you sleep there? Is that your land? You get it. Tell someone not to damn refuse. I tell you, is that where you sleep? And that is the slogan in Ghana. It's the country for
Yeah,
you alone. You
sure.
get it.
So
If if
Ima,
if
it's
there are
back
laws,
to what I said.
if
It
there are
starts from
laws,
you and then it
of the
continues to the
it
outside environment. We have to
it
all be responsible. We
very
all need
good.
to be responsible, despite the government in power is playing its part to curb this
Now,
pollution problem. We have
Germany
to
has
also be
banned the use of
individually
diesel cars.
responsible.
Say, Germany has banned the use of diesel cars. They are going green. These cars are rather imported to country called Ghana and other sub-Saharan countries to buy. Why can't we also say
Why you
no
are
to some?
planning? Are you not also planning to buy a car?
I'm not planning to buy a car now,
You
unless
are
I
not
get electric
planning to
car.
buy a car.
Electric car. Without that, I'll not buy any car. If
Okay.
it's not electric car, I'll not buy any car because of the toxins that it comes out of it. We all know. Not that we don't know, we know. But the thing is,
You
that is what we have now. Germany has banned the use of diesel cars. America has banned the use of diesel cars. Britain has banned it. Why are they importing it to Ghana? We are buying it in other sub-Saharan
yes.
African countries.
So it comes back to responsibility. We need to be
That is
responsible
it.
as individuals. Yes. So
And so,
it's
in as much as
let,
the two of us are doing our
let me also
part,
have
the government also do its own
yes,
part. Put in measures, put in laws and
exactly.
regulations to keep some of.
Exactly. Yes. Yes, that's true. So responsibility is key here. You see, if I saw your hand up,
Yeah, Doc, thank you. I wanted to find out about the phyto remediation,
can you
where
kindly
you
speak
said
up for me? Can you kindly speak up for
if
me? I'm finding it difficult to hear you.
hello, Doc.
You see, can you speak up for me?
Yes, what I want to put across is you talk about the phyto remediation,
Yes.
and then you said if the environment is highly toxic, trees can't grow there well. So, do we have certain species of plants that can
Come
withstand
again.
a
Come
highly?
again. I didn't hear your question.
Do we have certain
I
species
didn't hear
of plants
your
that
last
can
statement.
withstand those toxic
Yeah, yeah, that's true.
Hello, sir.
You see, if I'm listening.
Hello, Doc.
Yusuf, I'm listening.
What I'm saying, do you have certain species of plants that can withstand and grow very well in highly toxic environment?
Oh, so that, I mean, toxicity is relative. Just as we mentioned, we have contemporary absorbing sunlight. Okay.
Okay.
We have contemporary absorbing
Okay.
sunlight. Plantain. And when you go to Takwa, you are advised not to eat certain food crops because the rate at which they absorb these contaminants is so high. They rather choose from different areas. They will rather choose from different areas to go and buy from there than even to buy those things planted or, I mean, cultivated in Takwa and Bogoso and Pristia in other surroundings. Because these food crops will absorb these nutrients, or better still, this cyanide, mercury, selenium, and the stuff, which will be, I mean, problematic for your consumption. After your consumption, it will be problematic to your tissues and organs and the rest. Okay. So let's look at the unit 4 if the concerns are catered for.
Doc,
Yes,
Doc,
sir. Probably the
Pacho.
last one, then
Yeah,
we move on.
please, if you have chosen a site to remediate through the use of plants, how long is it going to take? Is it going to be 5 years interval where you continue to grow and harvest and or it's just a one-time something?
Okay, so it depends on the plant species that you are using. Okay, it depends on the particular plant species that you are using for such remediation, if that is
I,
okay for you.
I
Uh-huh.
understand we use dark wheat and then even our common sunflower.
Come again.
I don't know how. I understand dark wheat and then sunflower can be used in this
Dark
remediation
dark
process.
dark weed is a hydrophyte. Oh.
Oh,
Dark
okay.
weed is a hydrophyte. Are you
Oh,
talking
okay.
about the use in the soil or in the water? I mean, water contaminants.
In the soil.
Okay, so in the soil, dark weeds are found in, I mean, ponds and the lakes and the rest.
Oh,
So
okay. So
dark
that.
weeds are hydrophytes. They can rather, I mean, take up pollutant in aquatic environments. Okay.
Oh, okay.
Yeah. So
Okay.
dark weeds can take pollutant in aquatic environments. And
But
other ones,
the grass species, when I was reading, said grasses. So grass species, which one? Do you have specific one, or all of them are capable of doing that?
I think I've mentioned this already. I said there are some species of plants that will not be able to tolerate the concentration of these pollutants. Okay, concentration of these pollutants. Sometimes they can, I mean, when it goes above a tolerable level in that particular plant, the plant may die, even die, before you even come and uproot or harvest it for the incineration process. Please,
Oh,
are we okay?
I'm okay. I'm okay.
Uh-huh.
Thank you.
So that is it. Uh can we move on? I think you have a lot of interest in this, I know, but we also have for some your academic purpose. We need to finish up with the unit 4 so that you can take your quiz. You will do the unit 5 and 6 next week, and then you can take your quiz next 2 weeks. If we delay, we may not be able to finish. But then let me still listen to concerns from, is it Conjeli? Is the name right? John.
Yes, Doc.
Yes, sir.
Please, I want to find out. You made mention that when you go to Takwa area and Bogoso area,
Yeah.
you are advised not to eat certain food that is being produced there.
Yeah.
So in that case, what do they do with the food they produce there? How do they dispose it of? Because I
So
know definitely it's going to end up being consumed by some people
yeah, so they advise
who
you.
may not even be aware.
So sensitization is key here. I think it was mentioned by Ima when he was, I mean, submitting his concern as well. Sensitization, when you sensitize the local people that, oh, because of the pollution in our environment and in our soils, these food crops must not be planted. And the catch word here is must. You should not do it because the soil is polluted. And when you plant these food crops, plantain, cassava, cocoyam, and the rest, okay, they are going to absorb this cyanide, mercury, and the rest. And they'll be kept in their roots, their stems, and their leaves, some even in their fruits. And when you eat them, or when herbivores eat them, and you go and kill these organisms and you also depend on them, you are going to transmit these harmful or toxic substances through the food chain. And it is not that you have it and you are transferring it alone, but it will have some effect on your tissues as well, just as we mentioned. Okay, it will have some effect on you as well. So sensitization is key. Advise the local individuals where this pollution is huge or this contamination of soil is huge, like the areas I mentioned, Takwa, Bogoso, Pristia, and the environment. Okay, this contamination of this soil is huge, and it's not actually localized. The danger is that these contaminants are not localized. They are mobile. They move from one place to the other. So that is it. We have to just advise our individuals and then also sensitize them. And this galamsey thing must stop to save the generation.
Thank you, sir.
Yeah. So let's start with the unit 4. In the unit 4, we are going to look at industrial enzymes and polymers production. We're also going to look at some industrial production that are employing biotechnology. And then also the production of some chemicals through biotechnological processes. We'll also look at bioleaching, where mining will come in. We'll still look at mining. And then we'll talk about biofuel, and then biotechnology in some investigations such as fingerprinting and the rest. So to start with, let's look at some enzymes. So modern biotechnology techniques are raised, or better still, they are used in the production of processes to, induce enzyme production, which is needed for applications in other industrial sectors. And as you know, enzymes are very versatile tool, of which they are applied in different industrial processes. We use enzyme in production of yogurt. We use enzyme in even a washing powder and the rest, just to facilitate the process of cleaning of our clothes. Now let's look at some types of enzymes, and then we'll look at some substrates of such enzyme. We'll look at the reaction catalyzes or catalyzed by this enzyme, and then we'll look at the user sector that actually uses this enzyme. Now let's look at the very first one, or let's consider the very first one, which is the proteases. And the substrates we get our proteases from is the protein. And the reaction, what it does is it hydrolyzes the protein into shorter fragments. That is, when protein is digested, of course, obviously, you're going to get your peptides and amino acids. And the user agent or the user sectors that you are going to employ these proteases are, in detergents, like I mentioned, in washing powder, in foods, in pharmaceuticals.
Hey, hello. Is somebody here or is from my end?
He has gone. He's left.
You
It's
know
not
his
from
problem.
your end.
When he exercise patient, okay, we know his problems. When it happens, let's exercise patience and wait.
Hello.
Yes, sir.
Are we on break?
We are
No,
not on
no,
break.
he's
We are
off.
not
He's
on
off.
break. Because that his machine has gone off again. He's trying to see if he can set the slides and then we project it for him to have it.
It means that you were not
We
listening. It means that you were not listening.
I'm also suggesting that
exactly.
I'm suggesting we have it tomorrow, but he's also insisting that he wants to finish it today or in it, but he still insisted. So let's wait.
We have to get him the issue.
Go buy one for him.
You suggested it, so search for it.
So let's wait for a while. Maybe he will understand my point where we can have the class tomorrow evening.
Okay.
Oh, what does the AC has to do with the laptop?
Don't you
To
use laptop? Don't
reduce the
that it generates a lot
overheating.
of heat. It needs
Huh?
To reduce
laptop
the
that generates
overheating.
laptop don't like heat. People don't
They
know.
were saying that you have to buy him AC. So I don't know what the AC is going to do with the laptop.
Now you don't use laptop. That
Nana,
is why.
Nana Juma will answer this question.
Ima,
Hey,
Amposa,
yes, sir.
you know laptop generates a lot of heat.
Okay.
Very good. So
So,
when the temperature is low,
uh,
its heat production goes low. So it works
uh,
very well.
okay.
That is why I'm saying he should get an AC for the office so that it cools the laptop down.
Okay.
Thank you.
Well understood.
Hello, Mr. Koku. Mr.
Fidelia.
Koku Ajaman.
Yes.
Oh, afternoon. Please, are we going to have class tomorrow?
No.
Or it's cancelled?
Just 1 minute remaining.
Which class?
Now star 506 hash to continue talking now.
Which class?
Hey, who is
No
that?
class.
Which class? Fidelia.
The PCK. Oh, you know meet us tomorrow again.
The answer is no. We don't have class tomorrow.
On Sunday,
Hey,
you don't have
okay.
classes, though.
You know, we
Yeah,
discussed
no,
about
but
it on Sunday, so I don't know whether the Sunday was chosen or.
Please,
The
for your
issue is that the
information.
Sunday reading hold. We are
Oh,
meeting them Tuesdays and Thursdays. That's all.
oh, okay.
Okay, thank you.
I want to know that. Yeah. Thank you.
I'm not sure he can come back.
are you praying for that?
Not that, but
The laptop is on. The laptop is
not
on.
that, but I'm not sure he'll come.
The laptop is on. So he's trying to
Okay.
connect.
Okay.
You say kindly mute yourself. Without respect.
Hello, Mr. Amponsa.
Mommy,
Have you gotten it?
long time. I'll do that.
Then no, I've done mine.
Okay. Have you maybe
Elena,
submitted it?
you are in
You
class, so
submitted
please.
it.
Yes, I've done it. So don't
Believe you are
submit
in
mine.
class.
Okay.
I know. Mr. Ajima, I know.
After
I
this,
know.
I'll do that.
Okay, so yours only, not mine.
Okay. Okay. Okay.
Sir, please, let's go on. Welcome back.
Okay. Thank you very much for holding the fort. I don't know, the machine is misbehaving again. But then kindly give me a minute for me to share it with your course rep. So just in case it goes off again, then you have it and then you can go through it. So kindly give me a minute to share with your course rep.
Today is a very bad day.
Times like this, that's what happened. The other time when we had it around 4, I think we didn't encounter a lot of these challenges. So it's the timing. In the afternoon there, you know that.
This is weather issue. It's the weather, not any time. At times
It's
in
the
the
laptop.
evening we got problems.
No, the
At times in
laptop
the
is giving me
afternoon it is
problem.
okay.
It's not the network.
Uh-huh. That
What has nothing to do with the network? It's the machine that is worrying him. So it's not the time, just that the machine. I don't know. I don't know whether it's Toshiba or whatever brand. Some of these laptop nowadays, the least said about them, the better. So let's just hold on. When you share the slides, I will share it so that we can all get and read over it and then prepare for our exams. That is all.
Anna, I believe you will talk things over with regard to the quizzes and exams as to where to read for each, just like you did in the morning. And then please, if you have the slide for this morning, you can also share so you can have it then. Thank you.
Morning slides have been shared long time. Right after the class, I posted it.
Let me go and check. Thank you.
Right after class, I shared it. So kindly go to the biology platform. It's there.
Hello? Hello? Hello?
What is this hello for?
Hey, Mr. Kinsley.
Hello.
My hello? I thought you were not
What is
here.
it? Oh.
What I want to put a share is that my laptop or sometimes do the same, but when I see when it's becoming heated, it will generate some sound like so when I see that sound is coming, I just lift the back, then I put either a book or something there to raise it. When you do that, then the heat will reduce. It's when it gets contact with the surface, that is when the heat becomes too much. But when you lift it small, then it will subsidize. So that is the little that I want to share with us.
Thank you very much.
Please, I've shared the slides on
You
the
are
biology
welcome.
platform. Kindly go and download it. I've shared the biotech slides right away. Kindly go and download it. Frank, especially. Ejekum, go and download it. Thank you.
Mr. Opoku. Mr. Opoku.
Yes, Ohima Fidelia.
Please, please, the assignment Nana gave us in the morning. I couldn't screenshot, so please, I hope you put it there for us.
I'll
The
do
two
that.
assignments. Thank
I'll
you.
do that.
Thank you.
Okay, so thank you very much for your patience. I'm going to buy everybody yogurts. So those who are here, kindly list your names for me, and then I'll get you your yogurts in our next meeting.
All right,
That is
sir. All right, sir.
That is when I'm encouraged with your program. Come again. It should be shared in
Sir, please.
order.
Sam number 1.
Sir, please,
Okay,
let's
no
go before
problem.
it goes off again.
Right.
Hello, Doc. Can you convert the yogurt into 5 marks each, please?
Come again.
Can you please convert the yogurt into 5 marks each for us instead?
Lunch.
Into 5 marks. The yogurt, you convert the yogurt into 5 marks.
You don't have problem at all.
Okay, thank you.
And I promise the questions are not going to be difficult. They are going to just be straightforward. They are things that you have been hearing almost all the time. Okay. Yeah.
All right,
If you
sir.
attend lectures, the questions will be very easy for you. But then the situation where you don't attend lectures and you only read from the slides, that is where you are going to be, you are going to find difficulty in doing few things. But I promise it will not be difficult. It will not be difficult at all. It's all right. So come again.
Amen.
Yeah. So kindly let's continue. All what you have to do is to just read over what we have done from the slides. Nothing is coming outside the slides. So kindly read from the slides.
All the 6 units.
All the
6 units.
Oh, they are. I don't think it's something that is beyond you. It's not going to overwhelm you at all. You just read the slides. You can just put the manual somewhere. If you think the manual is voluminous and then it's quite difficult to read, just read the slides. You are good to go. Right. And I think I've simplified everything for you on the slides. So there's no need going for the manual. Right. So let's go on and look at the carbohydrates. So with the carbohydrates, that's a substrate. The type of enzyme is carbohydrates. And then the reaction, it acts on, hydrolyzing carbohydrate into sugar. And the sector industries or the sector, we have the food, we have the feed, we have the pulp and paper, textiles, detergents, and others. We also have the cellulases, and the cellulases, it acts on cellulase. The enzymes just ends with ASE. So that's, if you hear lipase, you are referring to lipids. If you hear proteases, it's acting on proteins. If you hear carbohydrates, it's acting on carbohydrates in that order. Right. We may have few ones that may, deviate from the norm, which is, amylase. If you hear amylase, whether salivary amylase or the other amylase that we have, it's simply acting on carbohydrates, and that is the polysaccharide. It acts on polysaccharide, or better still, some disaccharide like the maltose. So the maltase will act on the maltose, and then the amylases will act on the different polysaccharide like starch and the rest. Right. So let's continue. So lipases, like I said, it acts on lipids or fats, and they hydrolyze fat into fatty acids and also glycerol molecules. And the sector industry, you have food, effluent, treatment, detergents, pharmaceuticals. It goes on and on and on and on like that. Pectinases, pectin. Pectin is carbohydrate, and the pectin is polysaccharide. So kindly note that pectin is a carbohydrate, and then pectinase will act on pectin. And the reaction is it's mix of enzymes to degrade protein, pectin, and complex carbohydrates, that is a polysaccharide, in fruits. And pectin is found in fruit walls, like the tomato, guava, the rest, those ones that you are familiar with. and they are used in food beverage industries for clarification of those juices. Now, amylases also act on polysaccharides such as starch, and they hydrolyze it into smaller carbohydrates to form maltose and the rest. I mean, digestion, as we all know and we are familiar with. And the industries they act as we have food industry, you also have textile industries, print and those kind of things, polysaccharides. So we have enzymes for fine chemicals production account for about 5% of the world market. So the world market use, chunk of enzyme, different enzyme for different purposes. And the environmental assessment by enzyme production companies indicates that there's a long-term implication of, energy use and greenhouse gases, that is through their production. Evolution of those substances and also release of those uh, waste and sewage into some water bodies accounts for some form of pollution. So how do we actually address that? So assessments comparing the phytase production with the production of the feed additive monocalcium phosphate revealed less energy consumption, which leads to the reduction in greenhouse gases. So, which means that biotechnology has gone a long way of reducing these long processes and long chain of inducing these chemicals or production of these enzymes, chemically produced enzymes for such productions or processes. And also in these industries that we have mentioned, some these food industry, textile industries, and then detergent and other industries that we have made mention of. So biotechnology is coming in, and this time around we are just going to introduce some enzymes that are produced from organisms that are going to champion these reactions that we have induced from chemical processes or inorganic chemical processes. Now, biotechnology based polymers that has been produced. Now, you know that plastics and polymers are actually and currently the most used material worldwide. And for purposes of packaging, building, electrical industry, and automotive stuffs, these bags are used. And production is based on petrochemicals, and that are non-renewable resources, of course. Their raw materials and products are non-biodegradable, and so they leave some form of dent on our environment for it to be cleaned up, and they take years, years and centuries for them to degrade and finally form or reform the crude again. Now, in contrast, the production and the use of biotechnology-based polymers could reduce the use of oil-based products and waste. Now, let's look at some few biotechnology-based polymers. They include lactic acid, and then also the polyhydroxyalkanoate. In short, we mention it PHA. The full is polyhydroxyalkanoate. And then we also have the use of recombinant enzyme in conversion of acrylonitrile or acrylamide, and finally to polyacrylamide. These are some, polymers that has been produced through biotechnology. Now we have some other industrial production processes, and detergent is one. We can consider the detergent that we have been using. So in this process, enzymes from parts of the end products or enzyme from parts of the end products that the detergent to improve its performance when used by the consumer. Now you realize that when you are washing with normal water, the clean or the removal of some stains like protein stains, lipid stains, and all that, it's quite difficult because organic react with organic. And so what you have to do is that you need to have a detergent that will help you remove this thing. And in the production of this detergent, you have some enzymes that are, added into this detergent to help digest those things. That's the proteins. If it has to do with protein stain, it has to do with carbohydrates, or better still lipid stains. They will actively be removed. When it comes to, protein and carbohydrates, hydrolysis, they can be hydrolyzed easily in contact with water. But when it comes to lipids, lipids is quite difficult for you to, remove lipid stain with, I mean, water. What you have to do is that if you have an acid, you have to act acid, and before you are able to actually break those bonds, right? Either than that, what you have to do is that you have to have an enzyme which will serve as a catalyst for dissolution and removal of such lipid stain. So enzymes have been used in detergents since the beginning of 20th century, when crude pancreatic enzymes were added to laundry detergents. And in household or industry, the use of enzymes in household detergent result in reduced water consumption, and then also reduce washing times and reduce load of toxic substances in water. So they don't just manufacture these substances that we use or detergents that we use in our homes. One, the areas that they actually look at is your time that you are going to use to wash. It has to be reduced. So they introduce the catalyst, which is the enzyme, in the washing powder. Two, they also look at the energy that is going to be consumed. If you're going to use I mean energy, your manpower in quotes, to do the washing, your energy must be conserved, by reducing the washing time. Now, if you're using, the grid, the energy from the national grid, to which is electricity, the reaction of these enzymes in your clothes, which has been fed into washing machines, must react fast to remove those things, to conserve energy for you as well. And then also, after washing, the water that you are going to, or the sewage that you are going to feed into water bodies, they must also be treated. And you don't do it yourself. The washing powder, the soaps that you have been using, they do the degradation of these substances in your water that you're going to throw off. They do those reactions and degrade them to tolerable level by living organisms, or better still, for plant to absorb. So let's look at pulp industry, pulp and paper industry. So paper and then board are made of cellulose, and so the logs that they have been harvesting from our forests, they use some for paper works, and they are from woods. Hence, xylanases are used in bleaching process to enhance the extractability of lignin. Now, these cellulases and hemicellulases have been used in enzyme aided in the linking or the inking, when pulp from recycled paper needs to be cleansed of dirt and also ink. So xylanases are used, cellulases are used in manufacturing of this paper that we have and we have been using almost all the time. And some looks dirty, that must be cleansed. And you remember, if you can just take a look at, or have a retrospective look into those exercise books that you were using. Some are very clean and white, others too are, they look quite dirty. As in, not you cannot use, but they don't look appealing at all. So it depends on the enzyme actually that was used in the process of manufacturing, and the quantity that was used also affect the appearance of the paper. Now, enzyme aided removal of polysaccharide on fibers is applied to improve the drainage of water, and thus increasing the efficiency of pressing and also drying processes. Now, with the textile industry, our textiles, it can be gotten from cotton, and cotton is made up of these polysaccharides as well. Now, amylases is applied in the last step in textile, finishings, and in particular, for cotton fabrics to remove starch from cotton fabric after weaving them. And then also catalysis, mentioning some enzymes. Catalysis are applied to remove the superfluous hydrogen peroxides used in the bleaching step, and they are used in replacing repeated rinsing of the fabric in hot water during the textile production. And then also we look at the environmental implication are that these enzymatic processes in textile and finishing reduces water and energy. Once again, the focus is water usage and then also energy usage. So one, it reduces water usage. Two, it helps also to reduce energy usage and the chemical load in wastewater as well, to ensure increased biodegradability. Like I said, when you pour out the water after washing, you haven't actually done anything personally, but the enzymes that were used in producing this detergent that you have been using in your house, they have to go on or go a long way of degrading whatever substances that are found in the water after you using them to wash. Now, let's look at biotech in production of chemicals. There are other chemicals and substances that are produced through biochemical processes, and few of them have been listed. They include vitamins, they include the antibiotic derivatives, they include acids, and they also include bulk chemicals like the bioethanol. And they have been, shown on your screen or provided on your slides, few of them. We also have this cephalosporin. It's an antibiotic and it is naturally produced. And what happens is that we can have an intermediate form. We can have an intermediate form or derivative of this cephalosporin. Now, biotechnologically modified version of this naturally occurring form, cephalosporin C, has been produced by the action of this fungus, Acrimonium cryptogenum, on a commercial scale. And this, company, which is DSM, has introduced a fully biotechnological production process for cephalizin. And this is also an antibiotic, very powerful antibiotic. And it involves one fermentation process and two enzymatic steps. And this actually, the fascinating part of this whole thing is that it replaces the 10-step conventional production process, and it reduces cost by about 50%. And that is marvelous. If we can have biotechnology introduced into industries like this, cost is going to reduce, and then also energy is going to be hugely reduced. Like the DSM, their confirmation on the production of the cephalizin. Okay, 50% cost has been cut off. And then also, instead of going through a whole 10 steps to produce such powerful antibiotic, by the introduction of biotechnology or the use of biotechnological process, they have been able to use just 2 steps with the enzymatic process, and then also just a step in the fermentation process to come out with this powerful antibiotic. Now you also have, it goes same to look at the riboflavin, that is vitamin B2, the production of vitamin B2, okay, which is a water soluble vitamin whose deficiency has to do with, retarded growth and diarrhea and the rest. Now, commercial riboflavin, which is vitamin B2, is primarily used as a feed additive, and the fermentation process, partly using genetically modified organisms, has now largely replaced the intensive multi-step chemical process, during the production. So we used to have a very cumbersome, step to produce this particular vitamin. Of course, it's found in some food substances, but then if you want to, produce it at lab, you have to go through a whole huge cumbersome process, long way, very cost inefficient, and all that processes. But then by the introduction of fermentation processes, this particular riboflavin of vitamin B2 can be produced in shortest possible of step in production. Now, the use of microbial process seems to have resulted in significant cost reduction between 40% and 50% due to higher efficiency and lower material input costs, and then also less waste production. And you have to, at this point, clap for biotechnology. It's doing a lot in our industries, and a lot of industrial processes are now embarking on the use of biotechnology to facilitate and also reduce costs, and then also, yes, reduce their energy input as well, or better say the energy that is used in producing these chemicals and enzymes as well. Now, amino acid. I can go on in mentioning some of the chemicals or some substances that are produced through biochemical process. Amino acid like leucine and the rest, they are all, or the lysine, are all produced through fermentation processes, and they are all biotechnological, process and modes. Now, let's go to bioleaching in mining. Okay, I'm sure you'll be interested. So, bioleaching is the application of biotechnology in mining, whereby microbes, the moment you hear microbes, no, you are talking about living organisms, and living organisms is associated with biology. So, biotechnology, the use of their enzymes, molecules, or that particular organism in industrial processes of production of useful substance for the use of mankind or other living organism. That is a biotechnological process. So the moment you hear microbe, the introduction of microbe into a process, then biotechnology comes in. If it has to do with introduction of, it can be enzyme, it can be other molecule or derivative of this, molecule that we have been mentioning, then you're talking about biotechnological process. Now, these organisms include bacteria and fungi to extract metals from their ores. Now, bacteria and fungi, which naturally grow among rocks, are the most suitable among and applicable ones for bioleaching processes. Now, these microbes are acidophiles, that is, they thrive in acidic environments, that is between pH of 1 to 3, quite acidic, very, very high acidic environment. And they get their energy by oxidizing iron and inorganic sulfur compounds, and then the carbon from carbon dioxide in the air. So they can often tolerate high metal concentrations. So that is the reason why we normally fall on them in the bioleaching process. Now we have two main bioleaching processes. We have the direct bioleaching process, and then we have the indirect bioleaching process or bioleaching action. Now let's talk about the direct one first. So the direct one is when you introduce the bacteria. Example is the Thiobacillus peroxidans. When you introduce such bacteria into the environment, that is a mining site, what happens is that it acts on the ore directly to extract the metal. While these are susceptible to oxidation, the ore susceptible to oxidation, and they undergo direct enzymatic attack by these organisms. The ore is, subsequently or eventually extracted from, and then they are dissolved in a more soluble form. So let me just sum up the process. What you have to do is that they introduce the ferroxidine species, and when they introduce the ferroxidine species into the ore, now because it undergoes this, oxidation processes, these anions are extracted from their ore and they occur in a soluble form, and they are washed, and finally they are extracted. But the indirect one, what happens is that the bacteria produce strong oxidizing agents which afterwards react with the metal and extract them from their ore. So actually the bacteria is not directly involved in the process, but rather they produce their enzymes, and these enzymes are used to rather extract the ore. Right. So because they work in the acidic environment, it is necessary for you to keep them in there for indirect bioleaching to keep the ferric anion and other metals in a solution. So after looking at bioleaching, that is one application of biotechnology, we can also look at biofuel production. Now, biofuel is derived from organic matter, either directly from plants or indirectly from agriculture or domestic or industrial waste. And biofuel is a type of fuel whose energy is derived from biological carbon fixation. And high prices of fuel, coupled with dwindling amounts, have necessitated that they need to develop alternative form of non-petroleum based fuel, because petroleum is non-renewable energy. And so we can look at other mode of production or producing energy for our use, and we can fall on the use of some organic waste to produce fuel. We have types of biofuel, and with the types, you have the solid biofuel, which has to do with, uh, the coal, peat, wood, sawdust, domestic refuse, charcoal, dried manure, agriculture waste, and then other substances in solid form to generate energy. So we also have the gaseous biofuel, and it includes the use of sewage, the use of manure, the use of municipal waste, and also plant material, and for generation of these materials, or better so, these gases, which include methane. So the gas obtained thereafter is a mixture of, or is a consisting of mainly methane and carbon dioxide, and they are used as a source of fuel. You also have the liquid form of fuel, and there are two types. We have the bioethanol, and then we have the biodiesel. Let's talk about the bioethanol. So carbohydrates such as the hemicellulases and then also the cellulose in plant material are first then converted into sugar by hydrolysis, and then it is followed by fermentation, and after that we distillate it, or we undergo distillation process. Now, a typical example is the production of ethanol, akpeteshi. Okay, yeah. We can also have the biodiesel. The biodiesel. It is produced from vegetable oil or animal fats and short chain alcohol through, transesterification reactions. You can, this reaction converts an ester into a mixture of esters of fatty acid, and that makes up for oil or fat. And upon purification of the mixture of fatty acids to methyl esters, biodiesel is actually obtained. Now, let's also consider algae as a source of biofuel. Now, algae, you know that is a protist. It's a plant-like protist. And you have the algae as plant-like protist, and then they are very small aquatic organisms that convert sunlight into energy. So to say that they are photosynthetic as well. Some of these algae store energy in the form of natural oils, and under the right condition, what happens is that these algae can make a lot of oil that can be used or be converted to biofuels. Now let's pay attention to characteristics of algae for biofuel production. Now, how do we know that this particular algae is actually capable of, producing biofuel? And why do we even consider algae in itself to be a source of biofuel? The reason is that one, they have the ability to grow very fast, and they should produce large quantity of lipids, carbohydrates, and also proteins. That is one characteristic of an algae, which could be used for biofuel production. Then the next one is that they should be able to store energies, large amount of energy in a form of natural oils, and under right condition, they can make a lot of oil that can be converted late into biofuel. And you know that algae potentially produces up to 60 times more oil per acre than even land-based plants. And they also thrive on poor quality water, so that they don't even require freshwater resources, just like some other plants also do. So wherever small quantity of water uh, is available, they can actually use it. And it doesn't even depend on the quality of the water. All right. So algae can also grow on marginal or non-crop lands. Those lands that crops cannot be able to, survive. These algae are able to survive, and then they produce their oils. So there are some strategies indeed if we want to also fall on algae as form of biofuel, then there are things that we also need to do. Now, we also have the strategies line out on these slides as one. We have to alter the time and amount of expression of desired enzymes within the host fermentation organism. So we can actually engineer the organism to be able to produce these enzymes that are responsible for these fermentation processes. Earlier. Okay, we can engineer the organism to produce them earlier or within a shortest possible time. These enzymes could be produced. Now, we can also engineer the organism to manufacture novel or improved enzyme, and that comes with genetic engineering. You can engineer their gene structure so that they can produce, different enzymes that has never been produced. You can also improve fermentation strains of yeast and bacteria that efficiently utilize both cellulose and hemicellulose sugars. So, when it comes to fermentation, most of these organisms, yeast and bacteria, are involved. So, for you to improve, what you have to do is that you have to improve their strains or the strains, sorry. So, it's like species. So, within the species, you have strains of the bacteria. Within the species of yeast, you have strains of yeast. Just like coronavirus. Okay, the species, you have the coronavirus, but then you have strains of the SARS-CoV-19. You have strains of that virus. So we also have strains of these bacteria, strains of these yeast as well. And you have to improve those strains that are involved in fermentation. You have to look at look out for ways of improving their fermentation processes. Now you can also engineer some fast growing crops with high biomass and then yield density through efficient interception of light during photosynthetic processes. So if they're able to produce, much food during photosynthesis, you can engineer these crops as well so that they produce some carbohydrate and other cellulose that will be used in fermentation process to convert them to biofuels as well. Now, engineering of biofuel feedstocks that are resistant to antibiotic stresses. That are resistant to antibiotic stresses and more amenable to conversions. Now, we can look at advantages of biofuel. Why do you think we have to consider biofuel as, what do you call it? An alternative source of fuel rather than the traditional one that we have, the diesel, the petrol, the kerosene, and those ones that we have from crude. Now, the advantage here of biofuel is that it is renewable. It is always accessible as long as new crops are grown and waste is continuously generated or amassed. So when we continue generating waste, when we continue poo-pooing, okay, we can generate fuel out of that. And the fuel that we generate, we say that biofuel can be in a form of gas. You can generate methane gas out of that and use it as fuel through your poo-pooing. So since you haven't died and you continuously poo-poo, we can get fuel out of your poo-poo. So it is renewable. One point is that it is renewable. And it's also dependable. Each country has the potential of producing biofuel. Therefore, dependence on foreign fuel can be reduced. So if you have those extract or those source of biofuel, you don't have to really depend on outside for fuels, external fuels. And it also produce cleaner energy as compared to the crude that we have. The fractions of crude that we have, I've mentioned some, the petrol, the diesel, the kerosene, and the rest. So fuel offer low level of carbon dioxide, or the biofuels offer low level of carbon dioxide emission. And byproduct is less dangerous to human health and the environment when compared to fossil fuels. It's also a safe form of energy. It is also a safe form of energy. So bioethanol is water soluble and it is non-toxic and actually biodegradable. It is actually biodegradable. Right. So when it comes to cost too, biofuel has the potential of being significantly less expensive, and prices may not be determined by cartels. That today there is increase in petrol, tomorrow they have increased it again, the next day before you realize, you see, there are cartels that are, when you say cartels, we mean those in quotes, bad individuals
We know them.
want to
We know
just
them.
you know them, eh?
They are there.
And but
We know
don't
them.
mention anybody's name, please.
I'm not mentioning their names. We know them.
So we have them available. That will, you see, interestingly, they will create artificial shortage when they are coming to increase prices. Before you get your car to a fuel pump, they will say the fuel price is gone up, and so that's it. So another is the source material is more available. Okay, so biofuel can be manufactured from a wide range of materials, hence its production is not limited by area. I have so much interest in these advantages. So yes, with biofuels, let's all champion the use of biofuels. Yeah, like biotechnologists, let's find additive way of, coming out with this source of fuels, being liquid, being in a gaseous form, being in a solid form. But then they are actually discouraging the use of charcoal and the rest. And it's a biofuel. We used to go by it, and they said we should use LPG. And LPG, not LPG gas is not a biofuel gas. So what do we do? So please, we can do that by substituting it with methane, compost. We can get methane gas from compost, your excreta and sewage and the rest. So let's champion that.
Look, I wanted to talk about that, and you brought it up
Okay.
because sometimes that was the propagation that we should cease from the use of charcoal simply because we are cutting down trees.
Yes. Yes.
And another issue has to do with the bio gas. That is the use of the poo poo. My parents, when you go to these near highs, a lot of poo pooing. But why not take advantage of that? Is it
Come
that
again.
we cannot do it, or it's kind of difficult? Well, most of the senior high, if they were to be using some of these things, I think would have helped. Yet here in Ghana, nothing like that is happening. I don't know whether we have some secondary schools that are having it anyway.
Oh, I know of Infante Pimo. I know of Infante Pim school producing methane
Oh,
from
that's
their
fine.
excreta.
That's fine. So, Doc, how I wish that you champion these, and then some of us will also follow you, so that it should be all schools should have this, because we are wasting it, just wasting it. People are doing it, and the amazing part is that all the time we are bringing cars to come and collect them and go and dump it into where we end up
Yeah,
polluting the environment.
that's true. That's true. You have your point is valid. Your hand is raised.
Yes, I wanted to answer Frank that I know of at the other college, I know of Infante in central region
Yes.
schools.
Yes.
They use this kind of biofuel from
Yes.
ages. We have been using this kind of biofuel. So nothing go with the all the toilet facilities are being connected to one source, and that is what they use to power the kitchen and then do the cooking for us. So some schools are using it, just as you said. It's just that um, the science department are not putting their heads together to make this thing work, and then maybe they're not having the backing of the management. But schools can do that, and even within our communities, if we can put our heads together and come together, we can still generate some of these, because every day we are these ways they are going waste, as we call them wastes, but they are huge sums of money. That is what this man is trying to do. What's the name? Just Pond, gathering
Yeah.
all the wood and then use it. And beside even the gases, we have fertilizer out of it too that we can use for our farming to get more food and eat more and poo more. So it's a recycled thing. It's very, very, very important. Yes, that the country is not, maximizing the importance of it. So as new generation, we can take it upon ourselves and then come out with something better for the nation. Yes, some schools are using that. I know of these two schools.
Sure. All right. Thank you.
Sir,
Right. So let's forge on.
sir,
It's a hand up again. Right. So we also
yes,
have
please.
disadvantages. It's Irene. Are you speaking? Right. So we
Yes,
have
sir. Yes,
disadvantages of
sir.
biofuel. Yes, Irene, let's hear you. Ima, you can put your hand
Yes,
down.
sir. On the issue of the biogas, I realized Presec Legon also has one when I went for a camp meeting over there. But one of the
Yes.
things that I realized was that it's not able to, capture the entire community of Presec Legon. So it's like when there is light out, it can only cater for some aspects of the institution. And there was this complaint that the kind of machines and generators that are used within the institution, sorry, I said generators, the kind of machines that they use within the institution will not give them that opportunity because of the plants, the size of the plant. So I also believe if it is championed by the Ghana Education Service at our level, to get it to start from the senior high school where they have the boarding houses. I'm sure it will go a long way to help us. Thank you.
Sure. Perfect. Yes, it's champion because we have energy clubs. We have energy clubs and we invite them for conferences and all that. And they learn on those kind of things. So yes, we have these clubs, energy clubs that are, available, and they learn on these biotechnological processes on how to sustain the environment using other forms of energies without relying on these fossil energies. So aside that, let's look at some disadvantages that are actually associated with some biofuels as well. One, the lower energy in outputs. That's the challenge that we have. So can all the people in Fantipim Secondary School, the students, their people, can they power the entire school if we have to rely on that? Can they power the entire school as in administration, kitchen, everywhere? Okay, now that energy use has become very, key in our settings and then our industries and then our facilities. Can it do that? Can it serve that purpose? That's one disadvantage that we have. Now, we also have threat to environment, just as we mentioned, charcoal, the use of charcoal. Uh, Deforestation is bound to happen if we have to rely on that. You also have high initial costs. The plants that we need to set up for these processes to begin and to continue and to sustain it is not easy. It's capital intensive. We don't have to just scratch the surface and let it go. It's capital intensive if you have to go into it. Now, we can also have food shortage because almost all the plants that we'll be producing will be using them for biofuel purposes. And so we may end up, even the farmlands that we will be, developing for crop and better say living for crop production and all that will be use of biofuel, plants. And so we may end up not getting some even spaces for crop production, which will sustain the life of individuals and citizens. Now, you also have land shortage. It's still come back to what I was saying. So there is a concern about land use change in response to greater demand for crop to use for biofuel. And then also land earmarked for food production will have to be shared with crop meant for biofuel, like I just mentioned. So both for food shortage and then land shortage, it's quite a disadvantage to this particular mode of fuel that we have been championing. But of course, you compare both sides. Either you are talking about the low energy to shortage of land to shortage of food and all that, to the pollution of the environment. Which one will you go for? If you have to use large amount of energy, at the end of the day polluting the environment and causing so much harm to living organisms, and depending on small amount of energy which is quite clean, which one will you go for? It's something that we have to all deliberate on. Now we are inching to the end of this particular chapter by looking at DNA and fingerprinting, or DNA fingerprinting and profiling. So it also has some biotechnology aspects which we are actually going to look at. So this is a genetic typing technique used to analyze the genomic nomenclature between samples and to determine or identify at the genetic level, and then also compare the DNA pattern of individuals, or better still. And this is actually used in crimes. Okay, used in crimes. Of course, you can also use in paternity testing and all that. We will look at it very soon. So no two individuals, unless they are identical twins. Even with identical twins, there might be slight sequence change. Base sequence change. We have learned about bases. And how these bases form up or pair up to form sequences. and then all that. So there might be a small base sequence change when it comes to twins. I mean, identical twins, to be more specific. But then, aside that, everybody is different. I mean, when it comes to the DNA pattern, arrangement of the gene sequence. So this means that for each one of us, our individual DNA sequences is unique. A single human hair or a tiny drop of blood, semen or saliva are sufficient for us to identify your gene sequence or DNA sequence. How do we apply this fingerprinting in lives? So DNA fingerprinting is an important way of generating evidence in legal cases for inclusion or exclusion of persons from suspicion or in criminal investigation processes. So you are either investigated to be included, or you are either investigated for them to exclude you from a crime that has been committed, and they can use your fingerprinting, I mean the pattern of your fingerprinting, to determine that. It is also used in maternity and paternity testing, particularly to settle paternity disputes. I am the one who impregnated the girl. Now the child is being tested for, I mean, DNA, and my sequence also matches with the child. I cannot deny that. On the face of our traditional mode of determining whether I mean, using blood typing or blood group, I mean, it's not enough. It's not a very, I mean, good evidence to sustain for a fact that I am the one who impregnated the lady to give birth to the individual. But then when it goes beyond the, I mean, classical level to molecular level, when we use DNA, you cannot deny for a fact that because your gene matches with the gene of the son, that's not your child. No, you cannot deny that fact. Yes, Frank, I think you have interest here. Have you gone to impregnate somebody?
So we have it a lot, so I don't want to talk about that. Doc, the first one you talk about is what I wanted to comment. Sometimes you see
Okay.
that somebody will hold a gun, and by holding the gun, if you drop it and something happens, they can get to know that it is you who hold it. So I was wondering what technology is used that they are able to detect that you are the last person to hold a gun, or you use the gun for the criminal act. How is that done?
Okay, so you have cells. Okay, your body is made up of cells, and these cells are worn out almost all the time. When you clean your face, these dead cells are cleaned out. When you wipe your face, when you bath, when you touch somebody, when you touch an object, these dead cells are left on surfaces. So when you touch the gun, your dead cells are left on the surfaces of the gun or on the objects. So by forensic testing, they can just, I mean, get those dead cells and look at those sequences of the genetic sequences and then compare with yours. Okay, if you are nowhere to be found, it will be difficult for them to, I mean, confirm that it is you. But then they can also use your lineage, I mean, your family line, to track you. If indeed you are the one, they can use your family, or they have the suspicion that you are the one or you were involved and you are not there. They can use your family line, I mean, to trace you and to detect that indeed you are either included or you are not even part of the crime, or you are not the one who committed the crime. Yes. Ima, your hand is up.
Yes, I was just trying to say something in support of what you are saying. I watch this series on DSTV, CSI Miami, more of
Mm,
um, more of investigative thing, and then once there was one man series that I watched where a crime scene, somebody stepped in there. You know, whenever there's a crime, they barricade the place.
Yes.
The person didn't know.
So
He
that
stepped
so
in.
that others will not have contact with
Very good.
surfaces.
They cordoned the place, and somebody just stepped into the cordoned area, and then where he stepped, they used the footprints. They just took sample of where he stepped. I don't know how they did it. They placed some like something like rubber on the ground there. It picked the feet, the prints there, and that is what they used to trace and then arrested him. No, he has nothing to do with that connection, with that crime, but they used the feet, the cells, just as you said. They used that one to arrest him. But later on, they had a drop of the person's sweat on the victim where the guy was exonerated, and then they analyzed the sweats or whatever it is and then traced and arrested the guy who has moved far away to a different place in Chicago. Meanwhile, the thing happened in Miami. And
Yeah.
so I also want to encourage my colleagues, if they have chance, to watch some of this kind of investigative crime movies, and then it will give them a fair idea of what this DNA fingerprinting and what this kind of facial recognition thing. That is why nowadays everything has to be with fingerprint. It has embodiment of your whole cells in there.
Right. So thank you for the addition. And then also another sound of caution. Fidelia, you will come in. Another sound of caution is that those who have been almost touching everybody that they see, please be careful. Anybody that you touch, you leave a fingerprint on the person. You leave a fingerprint on the person. So please avoid always touching people indiscriminately like that, because you might not know what next may happen. Okay, so please, you are advised. You are advised. I'm not saying don't socialize, mingle, do everything, but then play a kind of caution when it comes to touching surfaces and also touching people. Please,
Say, if possible, wear gloves.
you are advised.
If
Okay,
possible, wear
Fidelia,
gloves.
let me have you, Fidelia.
Okay, thank you, sir. So, sir, please,
Yeah.
I want to know that due to these crimes and other things, should always be the last person who touch maybe a gun, or the last person whose fingerprint will be captured, or any other person. Maybe a person touched before the last person. They can't trace it to the actual person, but the last person who touched the item.
Yeah, so it might not, you see, it is not strict jacketed thing that when they see your fingerprints at crime scene, okay, you are suspected. The thing is that you are suspected if your fingerprint is, or your DNA prints is found at crime scene, you are suspected. It's not that they have confirmed or they have accused you, but then they have suspected that you could be part of the crime scene, or better said, the crime that was committed. Let me just put it right. We're part of the crime that was committed. Now, if you have your fingerprints at the crime scene, it's either you are the one who did that, or you know the person who did the crime or who committed the crime. Fidelia, are you getting it? You are
Yes,
either.
sir,
Please, I'm listening.
but my question was, would they be able to trace all those who got involved using their fingerprint or any other any that other thing that
Obviously,
or
they
only
might
the
not.
last?
They might not be able to test for everybody's fingerprint who was involved in that particular crime. If it's a group crime, okay. If it's organized crime that was committed, getting one person will aid you in getting others as well. Of course, for example, if I have Ima and then Frank and the others, maybe let me use yourself, Fidelia, Irene, and the rest. Okay, we organized and committed a crime. If they're able to get my fingerprint, trace and track me down, why won't I mention your names and direct them to wherever you are found for them to go and grab you? Should they waste time? Should they waste time testing for everybody's fingerprints before they get to know those who
The,
are involved. No,
the
just
brotherhood,
getting one person will get the rest.
the brotherhood must continue. If you do that, you have
Okay,
betrayed
sir.
the brotherhood.
Sir, please, my last question.
Okay.
Sir, this that you are saying that whenever you touch something, some of your dead cells will remain on that object. So
Yes.
assuming somebody has committed a crime somewhere, maybe
Mm-hmm.
using a gun, and then the person threw the gun away after some weeks or let's say more days, and later
Okay.
somebody went to see that gun and touch it, and upon that they went to investigation. Are they going to use the person who touched later cry?
Yours is more current on it.
Okay.
Yeah, yours will be there. And
Which
the
means
print is not left there forever. Oh.
Yeah.
Yeah, the print cannot be there forever. No. So the one who currently touched the gun and has the print on it will be the one to be arrested.
Okay.
Or will be the one to be investigated.
Okay.
Yes.
Wow.
That is why it is advisable when you get to crime scene, you don't touch anything there. You go and find somebody who is dead. Okay? You go and find somebody who is dead, and then because the person is your relative, you rush to the person, touching the person all over, carrying the person. No. You are not doing any good to the security personnel who are going to undertake the investigation. Yes. So please, when you see something like that, stay off, report the issue to the police for them to come and do their job. Don't be touching anything. When you get to such crime scene, don't touch anything there. Just
Okay,
stay
sir.
off. Yeah.
Thank you.
You're welcome. Right. So it is also used to identify plant and livestock diseases, such as characterization of organisms. Now, we have characterized corona, that's the COVID-19, that's the SARS-CoV-2. We have characterized most of the variants, and we know where actually they emerged from. And those variants that are even years to come, some of them have been characterized already. We also have characterized some polio viruses and other many more bacteria, fungal diseases have been characterized, and then we have some medication for them. And these are some of these ailments and diseases are associated with only livestock, like cattle, cow, pigs, and the rest. Okay, yeah. So we can use this technology to find out the sequence of gene of these disease-causing pathogens. It's also been used to ascertain food safety and food authenticity in industries. So as to whether the food is going to help or it is not actually going to benefit you when the sequence is determined, the gene sequence or the kind of protein that is produced in that particular food is determined. Of course, you know that the dogma of biology is replication, transcription, and protein synthesis, that is translation. So the kind of protein that is produced in such food is important, and it is key for them to track down that this is actually going to benefit you or is going to greatly affect your health. And so they check, even with the GMOs, they use this mechanism to track whether the gene inserted in that particular organism is going to actually going to be virulent. If it is virulent, it means it's going to cause diseases and is going to cause harm to the organism. If it is not, then what actually is the function of that particular gene? They use these sequences to determine particular gene function of a particular organism, which is even inserted in GMOs. Yes, Anthony, your hand is raised.
Thank you very much, Doc. I have this question. When it comes to
Anthony, can
Yes,
you speak up a bit for us?
okay. I want to ask this. When it comes to the
Kindly
testing of
raise
the
your voice for us.
okay, when it comes to the testing of the age of certain things, I
Testing
learned
of.
the testing of tongues, the ages of
Okay.
tongues. I'm
Yeah.
making a journal. I learned
Okay.
there's the use of this carbon
Carbon
examination or
14.
something. Yeah,
Carbon 14
yeah,
dating.
Carbon
yeah,
14.
yeah. I would like to know if that is part of it falls under this biotech that we are studying, or that's a
No, 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 no.
different.
Carbon 14 is it's a radioisotope. Okay.
Okay,
Yeah, we don't use it in biotechnology.
okay, okay.
Yeah, we
All
don't
right,
use
thank you
carbon
very.
14 in
Okay, thank you.
biotechnology.
All right, thank you very much.
Right. You can use it when you are doing ecology. Okay.
Okay,
If you
okay,
want to go into ecological studies, you can use carbon 14 to track sequence of food that has been eaten by organism from one successive level to the other. But you don't
okay.
use it when it comes to biotechnology.
All right.
Yeah,
Thank you so much, sir.
sure. You can also do, DNA profiling, which is used to determine species of archaeological discovery. Where they emerge from, evolution, and to track bloodlines of animals or humans remains from different geographic location and also geologic areas. Of course, so those who have traveled, these slaves that have traveled to, Asian countries, those Europe and the rest, we can track them using their genes, their DNA, to find out exactly which African country they actually migrated to go and be with the whites. So they can use the. I think there was there's some occasion in, I forgot actually it has
The
escaped
year of
me.
return. Year of return.
Very good, very good. Thank you very, very much. So most people, most of these individuals actually didn't know. They knew they were Africans, but they didn't know actually where they came from, or better so, their ancestry is from in Africa. So they use DNA tests to determine exact location, or better still, exact country that their ancestry can be found. So yes, it played a role. So DNA fingerprinting is also used as a tool for analyzing during dispute over kinship or throne. So if you are not supposed to be the king and you self-impose the kinship on you, they can just use DNA testing to do that, to track your ancestry. Your grandfather, your great great grandfather, and the rest. They can use DNA testing to do that for you. Frank and Anthony, is your hand still up, please?
Yes, please.
That is the last slide we will have. Then we end the class.
I'm wondering how somebody's DNA test can determine whether the person will be the next king. It's huge. There is one question I wanted to add when you close, but you brought it up and I wanted to chip in
Okay.
about the genetic foods.
About,
Do they have any influence on the person eating's genes?
come again,
The genetic foods.
the
Do they
GMOs.
yes, do they have any influence on the individual consuming it?
Oh, we have. Okay, you are now going to do your presentation on allergens. Okay. Now, these are chemicals that cause allergic reactions. So it might not change. Okay. There might be substances. We are all allergic to something. Okay. But what I have to tell you is that the gene will not, cause any mutation in your system. The gene which is introduced in that particular food is not actually going to cause any mutation or any change in your gene or your genome. This is what actually happens. Now, the protein which is produced by that particular gene that has been introduced into the new organism, you may actually react to the protein which is produced, and that becomes an allergen. Okay, and the reaction is called allergic reaction. Everybody is allergic to something. Even if the organism has not been genetically modified, you may react to it. Some people eat guava and they are reacting to the protein produced by the guava, some genes of the guava. Some eat banana and they react to it seriously. Some eat, I don't know, you have a lot of them.
Beans for blood group
Beans,
O.
very
Yeah,
good.
Ben.
Very
Yes.
good. And the rest. Even if the organism has not been genetically modified, we all react to certain proteins that are produced by these organisms. So it is the same. These genetically modified foods, there are some proteins that they produce, and what I may react to, you may not react to. So it differs from one person to the other. But for you to say that when you eat GMO or genetically modified food, it is going to change the structure of your genome, no, that is not going to happen. It is not going to cause any mutation in your system. Are you okay, Frank?
I'm very okay. Thank you.
Okay, that's fine. That's fine. So let's look at some case study on your screen. Some case study on your screen. Now, I'm just going to tease you with this one. Look at the first column is female, that's the mother. And the second column is for the father. And then 1, 2, 3, they are for the children. Okay, they are for the children. So if you check which of these 3 children belong to the male and then the female on your screen, which of these 3 children, based on their genetic sequences that is displayed, which of these 3 children and why? Then we end the class. It's just to tease your mind, then we end the class according to what you see on your screen.
That's 1 and 3.
Come again.
1
The
and
first
3.
child or the second child or the third child?
The first child.
The
third child.
Oh, be confident. You said what?
So the first child and the third child.
No, relax. One by one. Which of these children? First or third?
First.
I'm not hearing. Is it first or third? I'm hearing third. I'm hearing first.
First.
One.
I said first.
One.
Yes, sir.
Okay, so explain why. So the black dashes are gene sequence. Okay.
Yes.
So
sir.
use that to explain the gene sequence of. Let's go.
Of the first child, the gene sequence of the first child is matching with the female.
Okay. Is it matching with the male too?
It's also matching with the male. But
please, I'm listening. What about the second? What about the second? So do for all the 3.
The second only matches with the male.
Very good. Very good.
And it also match. No, it doesn't match. Okay. So only the male that the second matches with. And then
okay,
the
go to the third one.
The third one is matching with the male and then the female.
The third one?
Yes, sir.
Yes.
It's matching with the male and then the female.
The female.
Yes,
okay,
sir.
So what's your conclusion here now?
So it means
one child.
Those that are matching are they are taking some of the genes from the female and then the male.
So what's your conclusion? The 3 children. What's your conclusion on them?
So they are the biological children of the male and then the female, the father and the mother.
Which one of them?
No.
Those who are the first child. Wow. The first child and the no.
Fidelia,
let me help.
Okay, I think I saw Charlotte's hand first. So Charlotte, you to come in.
Yeah, per
Fidelia, you have done well. You have done well. Yes,
when you look at the in conclusion, it's only
No,
the
no. Start
third child.
your own. Start your own before you get to the
Okay.
conclusion. Start your own.
So the third child has a linkage with with the man, but
No,
not with
use
the woman.
gene sequence. We are looking at gene sequence.
Okay.
The gene sequence of the first child.
The gene sequence of the first child matches with the man,
Okay.
but does not match with the mother, the female. When
Are
you
you
come
sure?
to the second,
Look at on the app there. There's a gene sequence matching with the mother.
I thought maybe that is the before it moves. You know, I thought maybe that one is the before the gene begins to move. So I didn't consider the first one. I thought maybe the first ones are the sample taken. Then the subsequent one, when the sample begin to move through the gel.
No. That one is different. You are talking about gel electrophoresis. No, we are not doing gel electrophoresis here.
Okay.
This is a test result. This is a test result.
Okay.
So this is a paper. This is a paper handed to you as a medical officer.
Okay.
Or biotechnologist, or molecular genetic engineer.
Okay.
So how we interpret this?
So looking at the gene sequence, I would say the first child has the same gene sequence with both the mother, the female, and then the male. Then the second child.
When you say the same gene sequence, let me guide you. Okay, Charlotte, let me guide you a bit.
Yes.
Now, when you say it has the same gene sequence, it means the entire gene in the child matches with the mother. But when you say portion of the gene sequence,
okay. Thank you very much.
So come with that one.
So the first child has a portion, has similarity, a portion with his gene sequence matches with the mother, and a portion also matches with the father, the male.
Very good.
When you take the second child, the second child has a portion of the gene sequence matching with the male, with only the male, which is the father. Then the third child has a portion of the gene sequence matching with the male, and a portion matching with the female.
Good.
So when you look at it to conclusion, it means that two of the children, that is the first child and the third child, they have their gene. They both have portions of their gene sequences similar to the female and then the male. Whereas the third child has only one. It's only the second child has similarity with only the male, but not the female.
Okay. So in conclusion.
In conclusion, it means that the first child and the third child belongs to both the female and then the male.
Very good. What about the second child? Can you say something about the second? Okay, let me pick Ebenezer to talk about that one.
Belongs to the mother.
You have done well, Charlotte. You have done so well. Ebenezer, I'm listening.
Hello.
Yes, sir, Ebenezer.
All right. So also looking at hello, please, can I be heard?
Yes, we can hear you.
Yes.
Okay, so looking at it too, I don't know if it's how I see it, but I see that all of the three children do not belong to any of them.
Okay, so what's your reason?
Looking at the sequence of the father, I don't know if it's how I understand it, but looking at the sequence of the father, the father's sequence, none of the kids have something like that of the father's sequence.
Are you sure?
Are you sure? So why is everybody shouting "Are you sure" on you?
That's what
Are you
I'm
sure?
saying. I don't know
Are you seeing
if,
it well?
if that's what. Okay, so let me say something. So looking at how the father's sequence is printed. Okay, I don't know if it's from how I'm looking at it, but let me explain my point. So if you look
Okay,
at the
go
father's
ahead. Go ahead.
if you look at the father's sequence, there's a first line. Should I say line or what?
No,
Up
it's
there.
gene sequence.
Okay. So there's the first one up there, then one down there. Like I don't see anything similar printing here. All of them. Oh, hello.
We'll
Seven.
shout "Are you sure" on you again, no?
Well, that's what I'm seeing, though. But I can see the mother sequence in the first child's own and the third child's own. Yes.
Okay.
Yes, I can
Okay.
see the mother sequence, the first and the third. So
Okay. Okay. So let me go to Ebenezer. Let's go to Anthony too. Anthony.
Listen, I think the second child belongs to only the mother.
Which child?
The mother.
Oh, mother.
The father. Only the
Which
second
child?
child.
Which child? Which of
The
the
second
children?
one. The second child.
Belongs to
Only the father.
the father. Okay.
So maybe that is an away child from the marriage.
Fantastic. That's what I want you to say. I mean, that is where I want everybody to end. So it means that the first child and then the third child. It means that the first child and the third child, they are children of the couple. But if you check the second child, it has a gene sequence which matches only with that of the father. It has a gene sequence which matches only with the gene sequence of the father. But we can also say that the second child is a sibling of the third child. Is everybody seeing it?
Yes.
Yes. The
Yes,
second
sir.
child is a sibling. It's a sibling of the third child, but they don't have the same mother. So this is how they interpret this whole fingerprinting thing or genetic testing thing. So yes, we have actually come to an end of our unit 4. I'm sure, I don't know whether somebody is having a concern, but I can see some hands up. Juliana, Irene, do you have a concern? Juliana, Irene, do you have a concern?
No, sir,
Irene, but I think
I was going
my
to
concern has been addressed. So
Come again.
Irene is speaking now. I'm saying that I was about to contribute to it, but I think it has been answered by somebody, just as I wanted to also say.
Oh, okay. And Julie, do you have also something to say?
Yeah, mine was also the same. I was going to contribute, but Mr. Mens did that, so I forgot to put down my hands.
That's fine. So we have actually ended with the unit 4. Now I am having about 18 names for the presentation, but less than 50 people have been attending classes up until even now that we have ended unit 4. Well, that's okay, but please carry the message or the gospel to them that next week they are doing presentation on unit 5 and 6. The various portion that you're supposed to present on has been pasted on your page. I want to believe that your class reps, they've done that for you, or the course reps, they've done that for you. Kindly check the units that you are presenting on and the particular section of the unit that you are supposed to present on and do justice to it. Please, this is very important. Kindly, the slide that you are prepared with your group, forward it to me. Forward it to me by Thursday. Today is Saturday. Do that and forward it to me by Thursday. It's not anything hard to do. I'm not asking you for the whole unit. I'm just asking you to do section of a unit. And you're about 8 or 7 people in a group. Kindly do online coordination. I know you are scattered. So do online coordination and choose or appoint somebody to prepare the slide. And then afterwards, please, each one of you should go through the slide. And if it is approved, send it to me by Thursday. You have the manual with you. I think I forwarded the manual to your course rep, and he has also forwarded it to your group. So please, you have the manual with you. Kindly do that. Now, this is how you have to prepare your slide. Your slides must be visible. Your slide must be visible. Don't bunch up a whole lot of words on one slide. Make it readable for us, and please state it in points, and you can explain as you are presenting. Those who are not here, please kindly carry the information to them. Slides must be prepared and be received by me latest by Thursday. Please do that with your group members. And then also, in preparation of the slide, it must be readable. It must be readable. Then also, please state your name and index numbers. State your name and index numbers on the first slide. On the first slide, state your name and index numbers on your first slide. State your name and index numbers on the first slide, so that I will use that to score you even when you are presenting. And the last thing I will say is that, please, anybody at all in the group can be called at random to either start with the presentation or continue with the presentation. Kindly inform those who are not here. It is part of your continuous assessment. If I call you and you are not present, or if I call you, you are not able to present, it means you didn't take part in the discussion at all, and you'll be scored down. I'll look for your name and score you down. When it comes to content, I will score you down 0. So please advise those who are not here and have decided not to be here. Advise them that with the presentation, they have to take part. They have to take part. And it must be active participation, not passive one, because they can be called. They can be called to do the presentation, or they can be called to continue with wherever the one presenting has left. So please encourage your colleagues that next week is for scoring. Whatever we are going to do is for scoring. Please, those who haven't also submitted their work, today is the day for grace. A day for grace is today. Tomorrow when you submit, I might not give you any score. Tomorrow when you submit, I may not give you any score. So please encourage your friends. I have resent my email. It's the same thing, but then soon as possible. All right. Thank you very much. I can say, but
Please, my hand is up.
Yes, sir.
Yeah, please, thank you so much. But I'm pleading that with the work to be submitted, can you please spare us for tomorrow? Some of us are tight with other measures somewhere, so at times it becomes difficult for us. So please, I'm pleading that you spare us for tomorrow, so that we submit it. Hello, sir.
But it's been more than 2 weeks I gave you this
Please,
work. I think it's only one page.
Yes, please.
It's only one page, one page assignment that I gave you.
Yeah, you
It's been more than
it,
2 weeks,
but
so
I'm pleading that.
yes, let me hear.
Let's
Let me
make it
hear.
tomorrow.
Akumda, are you the one talking?
please, sir.
No,
Yes, sir.
Let's.
Please, sir.
Anthony,
My concern is.
come again.
Please, please, I was the one pleading that you spare us for tomorrow.
Somebody is speaking.
Sir, my concern is about the list or the grouping. I'm from Bolga Center. When we
That
check
is no
through,
problem at all. I know where you are coming from. That is no problem at all. This one is online meeting, so you can just do online meeting, and then
sir,
gather your thoughts.
please, sir, listen to my. I checked through our names are not there, and of course, the for Bolga Center said he has submitted the names to course rep on the 19th. So I was asking Ajimai, what is the way forward? Because when I went through the list, our names are not there.
Have you checked the updated list? I think the list have been updated. He forwarded some names to me. I updated the list.
Okay, sir. Then
Have
I'll
you
check
checked
it
that?
again. Sir, then I have to check it again because I went through it and I've not seen our names.
Okay,
Hello.
kindly check and then get back to me.
Hello, sir.
Yes, sir.
This one is not to say, it's to all of us. I'm pleading. We are having online class. So at times, if you go and post some information at a difference, most of them send it to the nationwide platform. And others who send it to the biology platform without me noticing it that this is from this place. The ones that I had, I forwarded it. Yesterday, I quickly sent the notification. Others resent it. That is what I forwarded to you in the evening. And you updated the forms yesterday night and submitted it this morning. I sent the updated ones too. So at times, we have to just be frequenting our page and know what is going on before. Because this one, I even sent it. And then I think Irene too or Mercy also resent it. That this is from Seth. So we have sent it. Just at times we don't visit the page and refresh ourselves with information there. So I'm pleading, all those that have sent their second list, I've sent it and it has been updated. Kindly go there, you will see your name, and then with your members start working towards the assignment. Thank you.
Okay.
Hello, sir. Hello,
All
Doc.
right. Thank you very much, Cost Rep. Thank you very
Hello,
much.
Doc.
Yes.
Please, my problem is with this presentation. You said we should send the slides that we prepare individually to you or as a group. That we should write our names and our index number on the first page. So please, are we to do that as the group or individually in the group?
Group. Oh.
Okay. So to answer you, you are supposed to work as a group, as a
Yes,
team,
sir.
and you can appoint one
Hey, I can't hear you.
I
That's
say
on
he
the
has
laptop
muted.
and
He has or muting a hole, Anna.
I can't hear.
it's not only you.
Oh, okay.
Hello. Is Mr. Akumda is there?
Hello. I'm back. So you are supposed to use the course manual as a guide. You are supposed to use the course manual as a guide so that whatever information that you have in there, if you want to add up, that's okay. If you want to pick that information and also use, that's okay. But you are not supposed to, do something plenty which will go beyond 15 minutes. You're supposed to present within 15 minutes. I will not allow you to go beyond 15 minutes. So something that is representative of the section that has been given to you is okay. But make sure you forward the slides to me on Thursday, and then Friday I will give you, whatever correction that I have to do, I will do it on Friday, and then give you a green light to it so that you can present it on Saturday. If you give it to me on Friday, I may not mind you, because I will not have time to be doing those kind of things. I will do everything on Thursday, give it to you on Friday, and then you go through and make your necessary corrections if there is any, and then you can present on Saturday. Please don't wait till that time, then come and give me excuses. I know you. Don't wait till that time and send it on Friday and give me excuses. So please, we have to be punctual and we have to be responsible. We know most of you are working, doing your own stuff and here and there. But then, so please kindly do yourself good, but adhering to timelines as well. Thank you very much. Yes, Anthony.
Please, Doc, I pleaded, but I couldn't hear any response. I'd like to.
But you still have time from now up to 12 a.m. You still have time. So can't you work in this space of time? Are you going to be occupied again with lectures?
Yeah, that's why so some of us we also tied up with some other lectures somewhere. So at times it's not easy.
Which lecture time do you have again?
For now, this month, for instance, I struggled. I had to attend to 2 lectures at the same time, and
Please,
so
you have
tomorrow.
up to 12 a.m. to send the work. Okay, I don't think I have to accept this excuse, because this assignment has been given
Yeah,
more
it's
than
true.
2 weeks, right?
It's true. It's
So
true.
why are
And
you
some of
using
us,
today? Why are you using today to come up with an excuse?
I was
Senior,
having some challenge actually with
it's
my
it's it's
hands
it's not
dirty.
helpful.
So,
At least
but
you can
this
let a friend help you. Your friends are having machines. Even if the person is not close to you, the digitalized world, or better still, digital world. if I should say it that way, you can call somebody. Maybe after writing it, you can type it on your phone, send it to the person. The person will convert it in word form, and probably you can add the email to the person, and the person can even send it to you directly, or send it to you, and then you can send the document to you, and you can send it. Is that something hard to do? It's not. It's not. It's just one page assignment too. It's not a whole book assignment. Hmm? Kindly
I
try.
understand. I
Yes.
understand that, but
Let me listen to your colleagues as well. Yes, Alex. Alex, your hand is up. Alex, your
Hello,
hand is
Doc.
up. Yes, sir.
Yes, hello, Doc. Yes, please, can you hear me?
I can hear you,
Yes.
please.
Okay, yes. Please, can we get a feedback on the assignments you've submitted so far? At least if there is any way, so that we will be rest assured that it has gone through. I'm becoming quite jittery because I don't know whether when I sent it, it has actually reached you. I know it
Please,
wouldn't be easy, but
when did you send it?
let's say on Wednesday, and then I also sent another one today to be very sure. So
Today, what time?
somewhere in the morning.
Somewhere, like what time? What time? Because we began the class in the morning. So what
Yes,
time?
I think that somewhere 11, as soon as as soon as yours started.
No
Yes,
problem. So I'll reply it. Okay.
Okay.
I'll go and check from here. I'm going to check my inbox and reply everyone who has sent the work.
Okay.
All right.
Okay. Thank you. Okay.
You're welcome. I think we are done. If there is no concern, we can end the class.
Hello, Doc.
Yes, sir.
Doc, I wanted to know which medium we will send the slides if it is prepared. Is it
Oh, the
through the
same
same?
email.
Oh, okay.
Kindly send it to the same email. Send it to the same email. Yes, Sammy, your hand is up.
Yeah, yes, sir. Please, I want to ask that if you look at the group, we are from different centers. So, and we don't also know their telephone numbers. So, I think maybe we can add a number so that maybe we can meet and be solving them.
So you can just ask those who maybe are presenting on unit 5, okay? Unit 5, section 6. I'm just using an example. Unit 5, section 6 to WhatsApp you privately. Is that okay? Is that okay
Okay,
with
sir.
you?
Okay, sir.
Yes,
Thank you.
you can just tell them that maybe, or can just post something like maybe those presenting on unit 5, section 6, kindly DM me or something like that, and they will reach out to you. All right.
Okay.
All right. Thank you for making up for this class. We hope to meet, God willing, next week Saturday. Have a good weekend.
Thank you, sir.
Thank you,
God bless
Doc.
you.
Enjoy your
Bless you
weekend too.
too. Enjoy your weekend too. Bye bye. If you have any
God bless
challenge to
you. Bye.
you can just reach out to me.
Yes.
All right, Doc.
Okay.
Answer. Nah, Adama Bewa. Another. So, I love